to continue our discussion of doctrines of the evolutionary world. And you'll recall what we've been looking at, from whether it be radiometric dating to homology and embryology and similarities between species, all sorts of things that are taught to prove that evolution prove its reliability and its validity as a worldview. And what we've been seeing is that sometimes those things are built off assumptions that are faulty. There were other times when they were just downright fraudulent. We're going to continue that today, and hopefully by the end of class we'll be able to kind of wrap up a lot of those and be geared up to move into the geological column and the fossil record on Sunday. So that's kind of our hope. Before Aaron leads us in our opening prayer, I think this verse will do well to get us started on our way today. Genesis chapter 1, 11 through 12 says, "Then God said, let the earth sprout vegetation, plants yielding seed, and fruit trees on the earth bearing fruit after their kind, with seed in them. And it was so. The earth brought forth vegetation, plants yielding seed after their kind, and trees bearing fruit with seed in them after their kind. And God saw that it was good." And kind of give us some things to think about as we get into our class today. So we'll allow Aaron to lead us in opening prayer and we'll begin.
Heavenly Father, we're so thankful to you for the day that you have blessed us with, and the chance to be able to come together and to study from your word, to learn more about the beliefs of our neighbors around us concerning evolution. Please be with us that we will have a better understanding of this worldly doctrine, that we'll be able to be better equipped to talk with people about the fallacies of evolution, that we'll be able to teach them the truth of your word. In Jesus' name we pray. Amen.
Amen. So we hinted at this on last week. We were talking about the English pepper moth. The English pepper moth is a creature that has been used to try and teach the acceptance of the evolutionary world. And what we really see with the English pepper moth is a creature that has two variations, if you will. You have what is typically seen with a white moth with speckled black dots across its back. Thus we call it the pepper moth. It looks like it's been peppered with something. And then thanks to a genetic mutation, you also see a black moth that is solid black. Instead of being white with the black specks, it's just a solid black moth. Now, what happened, the interesting thing that got a lot of people's attention, was reports of the English pepper moth seemingly changing. In the 19th century, the pepper moth, which was again typically white, suddenly changed its colors to black. And it's a new creature. Well, we knew that wasn't the case. Evolutionist scientists knew that wasn't the case. They're not claiming that at all. What they claimed happened was, because of the genetic mutation that caused some of them to be born this way, we saw a change in the environment that made it difficult for the white moths to survive, thanks in large part to the Industrial Revolution. As we bring in factories, and as more and more homes are begun to be heated with coal, and as cities are getting bigger and houses and neighborhoods are expanding, what we start seeing is a heavy amount of soot that begins to fall upon the surrounding trees. A very common place for the moth to go and park itself, as it looks for safety, or as it even looks for food. And so if everything around you is black, and you're a white moth with black specks on you, you're going to stand out like a sore thumb. And that's exactly what happened. The pepper moths began to die off. They would use a substance that grew on the trees called lichen. Am I saying that right? Lichen? They would use this substance that grew on trees that's very similar to we can see it on trees here. We might look at it and just think what's a form of moss of some sort, it's a fungus. But it's a whitish substance. Well, that begins to die off during this time as well. And so the things that they blended into best are dying off. The surrounds around them are turning darker and darker. It becomes harder and harder for the white moth to exist. What we see in the English pepper moth is a version of natural selection. Natural selection at its core is that the animals most suited for survivability in the natural habitat they're in are going to go on, and the ones that aren't suited for that are going to die off. And this is evolution. And it is taught in support of evolution. And as I said on Wednesday or Sunday morning, it is absolutely evolution. We must not be afraid of that. It would be foolish to just say that is absolutely false, that doesn't happen, it's not true. It is absolutely true, but it is used to support macroevolution. Again, macroevolution is large changes over large periods of time in different species, different kinds of animals. That is not what we see with the English pepper moth. We see microevolution taking place. And in fact, an interesting thing about this, the Bible talks about this very thing that happened. You might think, well, the Bible never says anything about the English pepper moth. No, it doesn't. But it talks about this very exact occurrence in Genesis chapter 30. Genesis chapter 30, verses 31 through 33 says this. This is Jacob having a conversation with Laban. He says, what shall I give you? Laban says this to Jacob, what shall I give you? Jacob says, you shall not give me anything. If you will do this one thing for me, I will again pasture and keep your flock. Let me pass through your entire flock today, removing from there every speckled and spotted sheep, and every black one among the lambs, and the spotted and speckled among the goats, and such shall be my wages. So my honesty will answer me for later when you come concerning my wages. Everyone that is not speckled and spotted among the goats, and black among the lambs, and found with me, will be considered stolen. Now what he was referencing was the very same thing that goes on with the English pepper moth, a genetic mutation in the lamb that causes some of them to be born without white, and instead they'd be born solid black, or maybe they would have some spots upon them, stripes in them that just made them stand out. Now, what do you think would happen? What do you think would happen if you have a large flock of solid white sheep and some solid black sheep and a few kind of speckled sheep that are mixed in, and a predator that hunts primarily like by night, such as a wolf or a lion of sort, comes into the area? What do you think is going to start disappearing first? The ones that show up really well in the moonlight, the ones that are very easy to be seen. This is not something that we would ever argue against. We see this happening over and over again. But what doesn't happen is those black sheep go on to produce a whole new kind of creature, a whole new kind of animal. They produce more of their kind. They produce more sheep. In fact, not every time will they just keep producing more and more black sheep. Sometimes as they mate with another animal, they'll produce a sheep that is solid white. The same thing was true with the pepper moths as well. And when their environment changed and when things began to clear up, guess what happened? The white moths started showing up again. They also discovered that there was a lot of things that weren't completely above board with the testing that went on with the pepper moth, such as the pictures that were taken to prove pepper moths' places where they rested. A lot of the people that played a part in those experiments, several have come forward and said, well, some of those moths were moths that we had actually purchased, and they were so inoculated that we would have to sometimes even lay them on the hood of a car and try to warm them up to get them to be lively enough to go and do what we wanted them to do. And there's connected to the footage, to the experiment, there's some footage of these moths that are just getting picked apart by the birds around them because they stick out so well. And some of the people involved in that have now come forward and said, well, those moths were moths that we just bought and we released so that we could get this footage. There's a man by the name of L. Harrison Matthews. It says the peppered moth experiments show survival of the fittest, but they do not show evolution in progress. L. Harrison Matthews, by the way, wrote this in the foreword of the 1971 edition of Origin of Species, Darwin's book. He is an evolutionist. He will readily admit this is not a depiction of macroevolution, but simply microevolution. Small changes within continents. Having said that, and in spite of these contradictions that we have pointed out, the claims of fraudulence and the claims of people interfering with the experiment in the way that they should, this is still continued to be put in textbooks. The peppered moth continues to be shown to school children today to prove that macroevolution is an absolute real thing. And that's what we're going to look at as we look through a lot of this stuff today. These things that are, if you go and get a science book, you go and get a textbook, you're going to find these very things that we're talking about. What you're not going to find is some of the truths that are omitted from them and some of the testaments of renowned evolutionists who say, we wouldn't use that anymore. And it reveals an agenda in certain cases to try and promote and propagate this view over top of other views. So, before we go on any other stuff about the English pepper moth? Anything that stands out to anybody else? I'm going to hit the highlights on some of these so we can try to get through them more. So if you all have thoughts to add to them, by all means, feel free to share them with me.
Well, it kind of goes back to what I think I said a couple weeks ago, that if this is a mutation, and I think there's some research that states that there were both these types from the get-go.
Right.
But in the speckled, Europe, where these, they have a lot of what we call European white birch.
Mm-hmm.
And so the speckled were definitely camouflaged, whereas the black, of course, these landed, they were going to get picked off. So they had to find another area to be more camouflaged. But then, like you said, the soot covered the European white birch, and so the white speckled were definitely picked off, but they were still there. It wasn't like they died off. But if there was a mutation and it's turned black because of that mutation, it can't convert back into a speckled.
Right.
So with mutations, you don't get progression; you get regression. It can't go back.
Yeah.
And so it's not an evolution. It's
de-evolution. Yeah. It's decay. It's degrading.
Right.
The creature is degrading. And we're going to talk about that hopefully in the class. This idea of mutation and some things that we need to know about. When people throw that word out, just say, well, these are mutations, and that's why we get evolution. What is it about mutation? Because there are some mutations that we would all agree, evolutionists, creationists, both. Some mutations that we say, well, that's obviously not something that's going to suggest that evolution is occurring. That is a problem. Cancer is a mutation of cells. That's not a depiction of evolution. That's a problem. So we'll talk more about that in a moment, but you're absolutely right. Mutations, specifically for them to be beneficial for the evolutionary view, must continue to mutate, and they can't go backwards. And yet that's what we see happening in a lot of these, is even if it is, like you pointed out, maybe two separate species, but even if it is one species that has this genetic mutation, whenever the environment changes, it goes the other direction. You see more, and what that details is these black moths are having babies that are white speckled, and then maybe while the environment is not good, they're getting eaten. But when the environment gets better, they start showing up again. Their numbers start climbing again. And the ones with the black, they're starting to decline because the environment is not good for them. So it's not a long-term mutation. It's mutation that maybe lasts for a generation, and then it reverts back. So, yeah, very good point. All right, let's talk about this for a little bit. Darwin's finches. First of all, I want to start this off saying if you are ever talking with someone, they say, well, you're just whitewashing history and ignoring all of the ways that the church has introduced terrible belief systems into the world. And what you hear first off everybody's lips, the Crusades, you're ignoring the Crusades and the terrible things that the church did during the Crusades. Number one, we're not saying that we believe in creation because the church teaches creation. We're believing in creation because God's word says, in the beginning, God created the heavens and the earth. It is not about a church's stance. It is about the validity of the word of God. And to lean upon that more, one of the huge problems that the church created, which led to a young man going, I don't see that in nature, and him writing a book called Origin of Species. Charles Darwin grew up going to church, the Anglican church, and they taught this, the fixity of species. Have any of you ever heard of this? The fixity of species? This was a new one to me. I wasn't aware of that until studying for this class. Fixity of species means exactly what it says. Species are fixed. And it's built off of what we started class on, a little bit of a erroneous view of it, but this is what the church in Charles Darwin's day was teaching. Genesis chapter 1, 21 through 25, let me read that to you. It says, God created the great sea monsters and the living creatures that move, with which the waters swarmed after their kind, and every winged bird after its kind, and God saw that it was good. He goes on in verse 24, let the earth bring forth living creatures after their kind, cattle and creeping things and beasts of the earth after their kind, and it was so. God made the beasts of the earth after their kind, the cattle after their kind, everything that creeps on the ground after its kind, and God saw that it was good. And so with this teaching, the church was telling people that there is the cattle kind, and there are no changes within the cattle kind. That's not what that says at all. And we recognize that. We can see that clearly in the world around us. Just blindly listening to whoever is telling you something is not a good way to go. It's not a good way to search for truth. We should examine things. We should examine the things that I'm saying. We should examine what other people are saying. We should also recognize that there are some things that are absolutely true. The Word of God has shown itself to be true. But what does it mean when it says after their kind? Well, Charles Darwin was told it means that if you've got a bird, if you've got a finch, for example, it's always going to look like this. And then he takes this trip to the Galapagos Islands, and he sees these finches. And they are very, very different. Some are large. Like if you look at L here, L has a very big head and a very broad beak. But B up here on the other hand, B has a very small head and a very thin, narrow beak. All of these different birds, Miss Carol, that just look slightly similar but have great glaring differences. He looked at all that, and if you're reading in your textbooks and you're reading about Darwin's finches, he looked at all this and went, evolution must be real. Except he didn't. He wrote it down in a journal and almost never wrote anything about it again. He mentions it like one time.
That is true.
He even said it almost seemed like it was just an interesting observation, and that was it. And he went on. Actually, there were studies that were done about this until the 1970s. In the 1970s, some scientists went and decided we're really going to try to figure out what's going on here. And so they captured all of K. It's called a medium, I wrote it down here, a medium ground finch. So they would capture these, they would weigh them, they would measure them, check their beak size, their body size. They would put a band on them so they could track them, and then they'd let them go. And what they found was in the mid-70s, around 77, there was a terrible drought. And 85% of these finches died. The ones that were remaining were larger than the rest. They had larger beaks. Now, when I say they were larger, their beaks measured a 0.5 millimeter greater in size. If you're curious what a 0.5 millimeter is, you can look at the thickness of your thumbnail. That is a 0.5 millimeter. That's pretty close to the exact same size, if you ask me. But they noticed they did get they were slightly bigger. And the bigger ones survived this terrible drought. But just 5 years later, when El Nino sent some very hard and long and steady rains to the area, you know what they found? They found all of those sizes that had died. They found them all repopulated. What it told them was that there is a fluctuation in the sizes of finches dependent upon the environment that they are in. And that can be a form of microevolution, but it does not support the idea of a shared ancestry and a shared new species that they're headed towards in the future. In fact, what they also found out was a lot of the birds that they captured were intermating with other types of these finches. And whenever they were doing that, they were creating a whole new species. And in the 70s, what these scientists started to come to realize is instead of getting all these various new species that might, we started out with 14 finches, but at some point we may have 25 different species of finches. So no, what we're actually seeing is we're maybe just going to have one. Because of all of this inbreeding and because of the natural selection getting rid of some of the ones that don't do well in that area, we're actually going the opposite direction, and we're getting to one creature instead of more. But what's interesting about all of that, also, besides the fact that it kind of goes the opposite way, is it details something. A word, I talked to Michael, I said, I bet you don't use this word in your class today. It details this: phylogenetic borders. I said, Michael, do you think you're going to use the word phylogenetic in your class today? He said, I'm pretty sure if I do, it'll be the first time I ever have. Phylogenetic borders, phylogenetic, or phylogeny, that is the study of the history, the evolutionary history of a species. So we're just looking at all of its variations. And what the finches are actually showing is that those differences in a species have an edge, and they don't go any further. It's not that you get to the edge and then they turn into a new creature. They get to the edge and they stop. And so all of the variations with the finches, and there are many variations, but they come to a point where they stop and they remain a finch and they don't change anymore. And that's very important, but it's very, very rarely talked about whenever we talk about the finches. Instead, it is pointed back to Darwin as a favorite of his in his Origin of Species. It does not prove macroevolution, and it does not prove that a finch will be anything more than a finch. Just like a cat will never be anything more than a cat, a primate will never be anything more than a primate, or a human will never be anything more than a human. It shows that there are borders to these changes that they can come up to, but they don't extend over.
Who put those borders in there?
Say what?
I said, who put those borders
And who put those borders in there? Who made them into these kinds? Yes.
Something else, well, it's been brought before, the time scale of evolution for these mutations to take effect and for populations to change and carry these mutations has to happen over eons of time. But there is the capacity, at least within some animals, to have a sudden
You mean like those animals?
So one I was thinking of was the axolotl.
Axolotl. Okay.
Yeah, axolotls are typically basically pinkish in color. They're water-breathing salamanders. But there are times when it can wake up one day being pink and breathing water, and suddenly become very dark in color and spontaneously become an air-breathing animal.
Yeah.
Nothing has changed in it genetically, in the sense that the genetic code is still the same, but it has metamorphosed, if you will, into the air-breathing animal.
Yeah.
So sudden spontaneous change, that an evolutionist would say, well, that happens over millions and millions of years to transition from water dwelling to land dwelling. Well, it can occur within the same animal almost instantaneously.
Yeah. Wow. Very, very exciting. Very good.
Like that.
So you brought up the axolotl. The fruit fly is a huge favorite for these sorts of experiments to show specifically mutation. Now, who can tell me the reason why that is? Why do you think that would be? Aaron?
You get a lot of generations very, very quickly.
You get a lot of generations. So a generation for humans is 10 to 20 years. I would say about 15 years be one generation to the next. The fruit fly generation is 10 to 12 days. Every 10 to 12 days we have a new generation starting. And so you can see the effects of mutations very, very quickly. You can study those. They have become favorited for experiments. They're also favored in science classes. A lot of classes that are showing kids how we can breed these mutations in and allow them to observe the changes. I've got one of them up here. But before we talk about the changes, I want to talk about PBS. And yes, PBS is probably one of the most evolutionary friendly children's programs, but that's not the PBS I'm talking about. I'm talking about the PBS evolutionary test. And what it stands for is persistent. The mutation must get passed down from one generation, it must become inherited, so that every generation, once you produce this mutation, they continue to pass it along to all of their offspring. It must be persistent, it must be beneficial. It is a mutation that promotes survivability. It makes things better for the species, the organism. So it must be a mutation that is good and helpful. And it also must help it to outcompete others of its kind. Going back to the pepper moths, a mutation that helps them outcompete, such as one being black in an environment where they are primarily in a dark area. It's going to help them outcompete. So it must be beneficial. The last one is it must be structural. It must change the physical structure of the animal. Now, this is not an either or. This is an entire test that if it is going to be a mutation that is plausible to suggest evolution, macroevolution can happen, then it must be a persistent mutation, beneficial to the creature, that changes its structural appearance. And the reason that we say that is because what evolution is telling us is a cow one day turns into a whale. And if a cow one day turns into a whale, that is going to require significant structural change to the cow. It is going to have to take place over a large period of time where it's passing those structural changes down. And every one of those changes has to be beneficial to the animal so that it can survive and outcompete the rest of its kind to make this new kind. If it can't outcompete, what's going to happen? The ones that don't have that mutation are going to continue to breed, and we're not going to get the change. So it's got to be persistent, beneficial, and structural. Currently, to date, there have been 0 mutations within animals that fully pass all 3 aspects of the PBS test. There are plenty that are persistent, that they get passed down, but they're not structural. They don't make huge changes in the animal. Or there'll be some that are structural, and yet they're not beneficial to the animal. And that's why I have the fruit fly up here. The fruit fly, wow. I think I intended for that to be something that happened earlier, not right in the middle of that slide. Miss Carol, my fruit fly just flew all over the screen. I think I was playing with my stuff there. So the fruit fly, what I have up here is a fruit fly that has 4 wings. Here's what happened. They discovered in fruit flies a mutation that appeared in one of the wings. And they recognized, hey, we should preserve this. This might teach us something about evolution. We need to do some tests on this. So they preserved this variation within this species that has this mutation, and they started selectively breeding it with others that had a mutation in different parts of their abdomens. And what they eventually created was a fruit fly that had 4 wings. And they said, look, this is the example that we're trying to show you. Evolution happens. But here's the problem. That extra set of wings doesn't work. And it can't fly anymore because of it. It doesn't have the ability to get off the ground. It also cannot mate. So it can't pass that trait on. So this is a great example of a mutation that is not, it is structural, but it's not beneficial and it's not persistent because it literally hinders their ability to persist. In fact, this was a quotation from from an evolutionist. They said, they x-rayed the daylight out of old Drosophila melanogaster. That's fruit fly. They x-rayed the daylights out of old fruit fly. They changed the eye colors from pink to white and red and black again. They changed the wings this way and that. They worked on the salivary glands. They increased and decreased the number of bristles. They strained and sweated for thousands of hours to change Drosophila into something else. What happened? 2 things. 1, the mutant flies either died over a period of generations, or they came back to their original normal conditions. This is where all of the mutations led. Not to a new species, to a species that was inferior, to a species that eventually reverted back to its origin.
Thousands of hours. You can see the agenda with evolutionists. They definitely want this to work out.
Yeah.
Yeah. So here's another one. How much time we have left? We've got plenty of time left. We may for the first time run out of material before we run out of class. We'll see. So here's the next one. I don't have a whole lot about this one, but I found it very, very interesting. And this is horse evolution. Now, have you all seen in your classes or anything, have you seen the horse evolution?
Just that they were very small and they got a lot larger.
Yes, yeah. So basically, horse evolution is there was a period of time where horses were knee-high. They were very, very small creatures. And of course, today we measure them with hands, and they're well over my head. They're huge. Some of them are massive. So we have fossils that we have found of these different size horses, and we try to date through the forms that we talked about earlier in class. And what we see is our modern horse, Equus, which stands at about 1.6 meters and has an appearance like what we see in a horse today. And then as we go further back in time, we're looking now at the middle Miocene rock layer, somewhere around 15 million years ago, where we have Merychippus. I'm sure I'm saying all these wrong, and probably somebody somewhere is saying that just proves you don't have a clue what you're talking about. So Merychippus is only 1 meter tall, much smaller creature. The tooth looks very similar though. Hoof looks a little bit different, but it's got a great similarity to it as well. Go back even further and we get Hyracotherium, which is the early Eocene rock era, 50 million years ago. This horse, if we can even call it a horse anymore, it's 0.4 meters tall. What would that put it at? About 1.5, 2 foot?
About 1.5 feet.
Yeah, 1.5 feet. So very, very small creature. It actually has a very different foot. You can see appendages, like fingers, toes coming off of its leg, but yet it's still a very similar tooth. This has been shown in textbooks, both in high school and in college, to show hey, we need transition fossils. We need transition fossils. Here's our transition fossils right here. We have fossils of this creature that eventually turned into this creature right here. Problem is that there's a lot of evidence that says these creatures all lived at the exact same time. That they lived together. A couple quotes that I have regarding these this work, and again, these are from evolutionists. The horse is the classic story of one genus turning into another. Now it's becoming apparent that there's an overlap of this genera and that there were many species belonging to each one. It's a very bushy sort of pattern that it is, I think, much more in line with the punctuational model. There isn't just a simple, gradual transition from one horse to another, and this is now becoming fairly well known. So this is from one evolutionist saying, hey, all that we've been using to tell people about evolution with the horses, it's not exactly what we thought it was. There's a lot of evidence that shows that these animals overlapped each other, and it's not so much different species, but just different variations of the same kind. So a very similar animal. Another guy says this, that uniform, continuous transformation of Hyracothurum into Equus, so dear to the hearts of generations of textbook writers, never happened in nature. He just flat out comes out and says that didn't happen. Any other things about the horse transformation, the evolution of the horse before we go on? So the last one I got for us is one that I think has probably been taught a lot more than I realized. But it was one that I remember hearing well before we were studying it in science classes. I remember hearing it from friends that I went to school with. And these were not in evolutionary debates. They were just, an interesting fact that I've heard. Oh, did you know that we have vestigial organs? Now, actually, I don't have a single friend that ever asked me, did you know we have vestigial organs? Instead, what they said is, did you know that you got a monkey's tail inside your body? And it's just, that's when we used to be monkeys, and now we don't need the tail anymore, but it's there in all of us. And I always remember growing up, like, I wonder where my tail's at. That's a weird thing. What does vestigial mean? Vestigial means the remnant of some pre-existing thing. We have a fantastic example of a vestigial item right here in Somerset, Kentucky. And it was one of the very first things that I noticed when we moved down here. And it caught me very much by surprise, but it became something that every time I saw it, it made me feel good. We have a Blockbuster sign. That is a remnant of a pre-existing thing that serves absolutely no use today.
We used to go to that.
You used to go rent your movies from there, didn't you, Robbie? In trying to find that picture, I found a great Reddit post about the history of that Blockbuster, about the reason why that sign's still here today. And since we have a little bit of time, I'll tell you, the guy that owns the Toyota dealership owns the property that sign's on, and he refuses to cut it down to have it removed. He says, I think it's the coolest thing there is. I'm going to leave it up there. He says, I'm never getting rid of it. But that is vestigial. Vestigial is the remnant of some pre-existing thing, and it is typically, and especially in evolutionary sense, tied to something that is now useless. So our former ancestor might have had a need for this organ, but as we have evolved, we've developed a means in which we don't need that organ anymore, but we still have it. It still is produced in us. And this goes to show that we have example of evolution. This proves evolution occurs. What was interesting is in trying to search for this, specifically this one right here, the appendix. The appendix is one of these vestigial organs. It was interesting that in the very same slide on this evolutionary screen, was this is a useless vestigial organ, and then here is its uses today. Which kind of cracks me up. So, I want to just give you a few of these vestigial organs that are commonly used. The appendix, thought to be vestigial, unused remains of an ancestor, now is described in medical textbooks as a well-developed lymphoid organ. Our appendix helps protect us from invading microbiological organisms. Can we survive without it? Yes. Yes, it is possible, but it's not recommended. It's not completely useless. And in fact, it is becoming, as with some of the others we're going to look at, becoming more common for people to try to find ways to not remove these from our bodies. Now, before we go any further, to say the appendix has no use in our body, what do I need to be able to prove that statement? The appendix has no use.
Just one person.
Without an
There is,
appendix.
it is a use.
So we need to have one person. But for me to be able to prove that statement, I need to have all knowledge of every possible working of the human body. And we are woefully reminded that we do not contain that today. The body reacts in ways that we still don't understand, and we still don't know how to reverse the effects of certain diseases and certain things that go on. For someone to say the appendix has no use is to arrogantly suggest, I know all the possible things that the appendix could be used for, and I'm telling you, it doesn't have a use. But, having said that, a lot of doctors, a lot of medical textbooks are now completely going against what some of the evolutionary books are writing about the uses of these vestigial organs. Here's another example. Tonsils. Tonsils, which have long been, hey, have you got your kids' tonsils out yet? That's one of the first things we do. They don't need those suckers. Cut those things out. Cut down on your ear infections and let's move on. The tonsils are vestigial organs that have no use. And yet, the tonsils are now being found, much like the appendix, to be lymphatic. And they are a first-line defense against pathogens that are ingested or pathogens that are inhaled. They do serve an important purpose. And there are more and more doctors now who are saying, except for extreme causes, you should keep your tonsils. Same thing with wisdom teeth. I don't have that one up here. Wisdom teeth are believed to be vestigial organs of an ancestor that needed those that doesn't need it anymore. And yet, your teeth can grow in without causing problems with the rest of your teeth, there's no reason to take those out. They might serve a purpose, but if they're going to grow in crooked, if they're going to grow in and damage your mouth in some way, we're going to remove them. Here's another one. This is the one I was referring to. The tailbone. The tailbone is a supposed vestigial organ that we used in our primate past that we no longer have a need for. Do you know your tailbone serves a huge purpose in your life today? In fact, everyone in this room is using their tailbone right now to sit there, or me standing here. Your tailbone is instrumental in supporting you in both of those actions. Your tailbone is instrumental in removing of waste from the human body. There are 9 separate muscles that are attached to the tailbone. It is a very important thing.
It's part of the pelvic floor.
Absolutely.
Our organs.
Absolutely.
Position,
yeah, it helps to support our organs. I don't think that I put. I didn't put it in here, but it's very similar to, I mentioned cows turning to whales. So inside of whales is a hip bone. And they look at this hip bone and they say, this is evidence of when this whale used to be a land mammal. Now it's a sea mammal, but it used to be a land mammal, and it had rear legs, and this is a leftover part. It's vestigial. It's useless. Except it's not. It's the exact same thing. It holds and supports organs in their place. It is instrumental in mating. They would not be able to mate without it. It is not vestigial. It is still an important part of that creature, and thus cannot be looked at as, oh, that's just a leftover part from days past. Another one is hair. Hair on human arms is said to be a remnant of our ancestors, that one day we won't have that anymore. Except the hair on your arms and the hair anywhere on your body serves an incredibly important purpose of activating different glands, promoting oils and secretions to come out to protect the skin, to help with temperature management, all sorts of things that serves as to show it's not vestigial. It's still active and still necessary today. The last one that I've got, I'm out of slides, but the last vestigial one that I have is I think quite a common one, and that is the wings of flightless birds. Your ostriches, emus, penguins, kiwis. Huh?
A kiwi.
A kiwi, exactly. These birds that have wings that they cannot use anymore because they don't fly. They are vestigial. They are useless from a time in the past when they used to be an animal that flew. Except they're not. They're not useless. They all use their wings to control themselves while they run, keep their balance. Penguins use their wings to control themselves while they're both sliding and swimming. They use, I'm sure, I know the emu and the ostrich, I'm sure the kiwi, similar, they use that to control their body temperature. So to suggest that these have no uses, they're just vestigial leftover remnants, and this proves macroevolution, is to completely deny that which is false, or that which is true. These things still have use, and it's almost as if they were designed for the creature, the species that they are in. So, that's everything that we're going to look at with these doctrines. I hope that what we've recognized is when someone says, you don't believe in evolution, what about this? What about carbon dating? What about vestigial organs? What about all these things? That one, we need to understand that in some cases that those sciences that were very, very accurate were also built upon faulty assumptions, and sometimes they were just downright fraudulent and ignoring facts to greater their hypothesis about the evolutionary worldview. People that hold those up as truth, they may not know any of that. They may not be your enemy, but it can help you to try and have a peaceful conversation with them if they'll allow it. Aaron?
In our society, we hold up science to be above human ambition and human emotion. But people were doing science, and if science were done perfectly, then it would be wonderful. But you have people who have a pet hypothesis and who have perhaps hundreds of thousands of dollars in grant money on the line if their hypothesis is wrong. And it's certainly tempting to ignore data that goes contrary to what you have proposed to happen. And so it happens more often than it should. But as in the case of evolution, I think you see a lot of that as well.
Yeah, so that's a very good point. Whenever humans are making the tests, there's always there's room for error. Absolutely right. All right, thank you guys so much. Lord willing, Sunday we're going to book it through the geological column in the fossil record, so that by the following Sunday we'll be back on track.